Good morning, students. In our last classes, we were discussing about electric dipoles. We calculated the electric fields at different positions for the dipoles. Now today we will discuss about the torque on a dipole. In that case, whenever a dipole is placed in uniform electric field and a couple will be generated there for two charges, and as a result of that it will start to rotate, and in rotation we know there will be a torque acting on it. To calculate that torque we have to calculate the force and the perpendicular distance, and their product will give us the torque on the dipole, and that expression we will get is Pe sin theta, where P is the dipole moment and E is the electric field in that region, and theta, as you know, the angular displacement of the dipole. Also, along with that, a new property or new topic we are going to discuss, that is electric line of force. Already you have learned that if a point charge is placed in electric field, then it will experience some force. Now if that charge is a unit positive charge and it is free to move, then the path it will follow will be taken as the electric line of force or the field lines. These field lines always starts from positive charge and ends at negative charge, and they repel each other along their length. The most important feature of a dipole is that if you draw a tangent at any point on this dipole, then that tangent will give the direction of electric field at that point. Also, two line of forces can never intersect, because if two intersects, then at the point of intersection you will get two direction of electric field, which is practically impossible. That at one point you can't get two direction of electric fields. That is why two electric field lines can never intersect. Also, for discrete positive charge, the field lines will start from that charge and will end at infinity, and for discrete negative charge they will come from infinity and end at that negative charge. Now from these line of forces, in our later classes we will know that how electric flux generated and those things. Also, along with this, I'll provide some solved examples of numericals. From those you will get some idea how to solve numericals regarding the electric fields. Now the concepts already I gave you, that electric field is always directed from higher charge towards the lower charge or from positive charge towards the negative charge. So when you will solving those, don't use any sign, just use the proper direction, and the net electric field in that region, in a certain region, if all the fields are in same direction, then you have to add, and if all the fields are in opposite direction or two fields are in opposite direction, then you have to subtract. It is true for all the charges, that may be more than two charges also. And most important of all, that the point where you are calculating the electric field, you have to assume a unit positive charge, that is plus one charge at that point, and depending on the units given of the charges, you have to assume or you have to take the SI system or CGS system.